Problem of the day number 22. Now let's look again at angle pairs in a more complicated situation. Okay, so we still have all the different kinds of angles and parallel lines, and they give us some measures, and we want to basically find all the other measures in the diagram. So let's look at this example. So they tell us that PARK, and this symbol is for a parallelogram. Okay, so in case you forgot, a parallelogram is basically a figure with four sides where the opposite sides are parallel to each other. So that means that PK is parallel to AR and PA is parallel to KR. So that's what it means by those two are parallel. Okay. And they also tell us that PB is parallel to CR. So PB, 1, 2, I'll do 3 arrows this time, is parallel to CR. So we have a lot of parallel lines going on. So that kind of gives us a clue that we're going to be looking for a lot of parallel line angle pairs. Okay, so for example, corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles. That's the kinds of angles we're going to be looking for. Okay, and all they tell us to begin with is that angle 1 is 40 degrees. Angle 7 is 65 degrees. And angle 9 is 100 degrees. And we're going to use everything else that we know about angle pairs in order to solve for all the other angles. Okay, so the first thing that I would notice is this angle 9 is a linear pair with angle 10, which means that they're supplementary and add up to 180. So that tells me that angle 10 is going to be 80 degrees. Okay, and then I would focus on this triangle here because all three angles in a triangle add up to 180. So those two, angle 1 and angle 4, add up to 120. So that means that angle 8 needs to be 60 degrees in order to add up to 180. Okay, all right, then I'd probably focus on this triangle over here. Again, the angles add up to 180. So these two add up to 165. So that means that angle 6 would have to be 15 in order to add up to 180. And then let's go from there. Now we haven't used any parallel line ideas yet. So let's look for parallel line angles. Okay, so for example, if we're looking at PB and CR, if these are the parallel lines and this is the transversal, that means that angle 9 and angle 11 are going to be alternate interior angles. So the toughest part about having a diagram like this where there are a lot of different parallel lines is being able to identify which lines you're looking at are parallel and which one's the transversal in order to identify, okay, are these, same side interior, alternate interior, corresponding, like what kinds of angles are they? And so what helps me is to really focus on the two lines and then which one's the transversal. So that's how I know that angle 9 and angle 11 are alternate interior angles. And because they're parallel, that means that they're going to be congruent. So that means that angle 11 is also going to be 100 degrees. And angle 11 and 12 are a linear pair. So that means that angle 12 is going to be 80 degrees. What else? Let's see. Okay, so if we focus on PA and KR are the parallel lines and KA is the transversal, then angle 2 and angle 6 are also alternate interior angles, so they're also going to be congruent. So because angle 6 is 15 degrees, that means that angle 2 is also going to be 15 degrees. Okay, so angle 2 is also 15 degrees. And again, let's focus on this triangle here. And again, all the angles in a triangle add up to 180. So that means that angle 3 has to be 65 degrees. Then what else? Okay, now if we focus on these two lines, so PK is parallel to AR and AK is now the transversal between these two lines, then we know that angle 1 and angle 5 are going to, again, be alternate interior angles. So that means that angle 5 is also going to be 40 degrees because alternate interior angles are going to be congruent if the lines are parallel. So angle 5 is 40 degrees. And again, let's focus on this triangle now, and all the angles in a triangle add up to 180. So because those two add up to 120, that means that angle 4 needs to be 60 degrees in order to add up to 120. And if you look at all three of these angles, these all add up to 180. But because it's not just two angles, we don't call it a linear pair because a pair is two angles that add up to 180. So we don't have a special name for this. All we know is that these three angles add up to 180. And so because these two add up to 125, that means that angle 13 is going to be 55 in order for all three of them to add up to 180. And I think that's all the angles that they've asked us for. Okay, so let's fill in our chart. So that means that measure of angle 2 is 15 degrees. Measure of angle 3, where is angle 3? Angle 3 is right here, is 65 degrees. Angle 4 is 60 degrees. Angle 5 is 40 degrees. Angle 6 is 15 degrees. Angle 8 is 60. Angle 10 is 80. Angle 11 is 100. Angle 12 is 80. And angle 13 is 55. Okay, so in a diagram like this, when they have a list of angles that they want you to find, I recommend that you find the angles in the diagram first, and kind of keep track of all the angles that you have and all the angles that you haven't found yet, and then go back and fill in the chart that they're asking for. I don't recommend that you do each one individually, separately, unless they're changing the information between each problem.